Welcome, this is SPSS, PSY 3840, and I'm Professor Coolidge, and we are up to Unit 15. We'll come down here and we'll see that the ANOVA split-plot design. So here we had a two-factor ANOVA, and these are two independent factors, but different subjects under each level of all the factors. Here, the split-plot design is what they also call a mixed design. So here you have two independent factors. Here one's independent factor and one is a repeated measure. That means all the subjects get one of the levels. So we'll click on this unit. We'll go into this lecture. And we say that this split-plot ANOVA actually gets its name from the agricultural roots of the discipline of statistics. That's a pun. It literally refers to plots of land split up. Each plot of land receives a different treatment, like a different fertilizer or a different amount of water, but all of the plants in one plot are treated the same. But the plants from plot to plot are treated differently. So split plot ANOVA thus indicates one main effect in a factorial ANOVA is completely randomized, different participants under each level of one factor, but under the other factor, the other main effect, they get all levels of that main effect. So we're going to go into the social facilitation data set, which we've already entered, and that's right here. And I'm going to go down here and open it up. And there's our data set. Now, normally, SPSS makes this just a little bit difficult because notice here, this is our social facilitation factor. So we have level one was these 6 participants were all alone. These 6 participants were all observed. Remember, if we forgot that, we could go into variable view, go into social facilitation factor, and we see 1 was alone, 2 they were being observed while they performed each subject performed these 3 trials. Now back into data view here, and what you see here is here's how it would normally be done. Let's go to File, New, Data. So normally, let's go to variable view. Normally we'd have social facilitation, social fac, and here we'd have, in this variable, we'd have trials, data view. So in normal two-factor ANOVA, and you know what I'm going to do is add one more variable here in data view and have our dependent variable. I'm going to put depvar, dependent variable, and go back to our data view here. So here you are either in the social facilitation or you are alone or you are being observed. Okay, and here you'd have trial 1, trial 2, trial 3. So we could just code it this way. And actually, let's do these 6 participants. 1, 1, 1, 1, 1, 1. So notice now all of these people, each of these 6, were not observed. And they had trial 1, trial 2, trial 3, trial 1, trial 2, trial 3. And then we'd have what was this person's score, the first data point, on trial 1, and what did they score? And they scored a 9. But SPSS won't do it that way, because you can't run the dependent variable, I mean the other repeated measures variable, by coding it in this way. So that's why, let's go back here. We'll go recently used data. We'll pull up our social facilitation data. It's already open. Open in a new window. We'll open up our data in a new window and see what we have to do here is now we can code this variable, social facilitation, because it's the completely randomized. The 6 people who are alone and the 6 people who are observed, and you have to code a separate level, almost a separate variable. I mean, not almost, it is a separate variable for each of the 3 trials. And that'll allow us, and you see from our data on page 316 in our book, this 977 was subject, the first subject, who was alone, social facilitation alone, and their score on trial 1, a combination of speed and errors, trial 2, trial 3. So the repeated measure then has to, all levels of the repeated measure have to be treated like separate variables, where social facilitation, the independent factor, can be coded in one column. So we'll go analyze. Go to general linear model. We'll come down here to repeated measures. And now notice it said factor 1, and we're going to call that, this is the within subject factor name, and we're going to call the within subject factor name for all of them trials. How many levels did we have? We had 3. So we add that. What is our measure name? Well, this was actually errors. We add errors. And we'll go to define. And now what we'll do is, says within subject variables for these 3 trials. And it's just bizarre requirement. But if we click this over by SPSS, it takes it for trial 1 errors, trial 2 errors, trial 3 errors. What's our between subjects factor? That's the social facilitation factor. And we'll hit OK. This right here allows us to know that we, at least if there were 6 people alone and 6 observed, if we made a mistake coding that data, we'd see that this might be 7 and this might be 5. So we can see we did at least code that part correctly. Now, this is a little bit difficult, and this is part of our lesson for today, is looking at how do we find our source table. Look at all this that SPSS prints out for a source table. Unbelievably messy. So if you look in your books at the source table on page 321, you'll see a normal source table. And the first thing we see is the social facilitation factor, the between subjects variable, and its sums of squares, and its F value in degrees of freedom associated with its own unique error term, which had a sums of squares of 644, and notice its mean squares of 0.64. That's on page 321 in your text. So let's go down here and find out, well, let's go up here first. Where's our between subjects variable? So I don't see it. I don't see any titles. Within subjects effects, within subjects contrast. There it is, tests of between subjects effects. We don't need this intercept, but there it is. Remember we talked about the sums of squares is 53 point, this is rounding error, 0.78 that was in the book. And then the error 6.44. Remember the mean square here is this divided into this, which just means move the decimal point over, 0.644. And so this is the first part of our source table. 1 degree of freedom, 10 degrees of freedom for its error term, because the independent factor gets its own error term. And this would be the first 2 things, just like on page 321 in the source table of the split plot ANOVA. With these are correct, these 2 are correct, these 2 are correct, and it yields an F value of 83.45 if we round it off. The book is a little bit different, and that's because primarily there's rounding error. Both, there's a little rounding error in the book, and there's a little rounding error here in SPSS, because it actually only calculates at the 4 decimal places. Okay, the next thing we see is trials. Okay, trials is a within subject variable. If we go up here, here's a within subjects variable. Sphericity assumed. These are some of the assumptions of the test, but since it's robust, we're not going to bother with them. Our book says we're looking for a sum of squares of 1072. So there it is. 2 degrees of freedom, 5.36, exactly like the book, and an F value of 6.31. So this is a rounding error, but 6.35, and there's our level of significance. So the next part of our source table is this line right here. Trials, sums of squares, degrees of freedom, mean square, F, and your significance level. The next entry in our source table is going to be the interaction, and that's a trials by social facilitation. And we're looking for a sums of squares there of 239. There it is. 2 degrees of freedom, the correct mean square, and the correct F. The next entry in the source table is this errors, trial errors, and this is our error term. And you can see we're looking for sums of squares of 16.89, 20 degrees of freedom, which is correct, correct mean squares. Of course, this is the error term associated with the within subjects variable. Notice this is the error term also for the within subjects variable with the repeated measures. Here's the repeated measures. Here's the between subjects variable. So it requires its own error term for both of these entries in the source table. And so this finishes out our trials, our F, and this one is not, the interaction's not significant. So the only thing we'd have to run a post hoc test would be on this trials variable here, because social facilitation only has 2 levels. And where was that? Oh, that was down here. So the between subjects variable, this was significant, F was significant, but notice number of levels minus 1, 2 levels minus 1 is 1. So what we've got is no post hoc test necessary there. We do have a post hoc test necessary for trials, but not for the interaction. And so we can actually run then Tukey's test legitimately on this, because we can see there's a difference in the errors. At least one of those means under trials is significantly different from one other. And that's why this SPSS printout, this in the statistics viewer, this output is a little bit tricky to interpret, because it also gives us this trials with tested within subjects contrast, which is something different. It's not what we'd have in the normal source table. And that is our lesson for today.